Hello students, this is my first ever video. I don't know how I will teach you, but I think I can clear all the doubts from the chapter electricity. First, from this chapter we will study electric current. To understand this electric current, there are two terms. One is electric and another one is current. So if we define these two terms, then we can know what is electric current. First, from the term electric, the word charge is coming to our mind. That means electric means the charge, and the current meaning is flowing. This is charge. That means the term electric current means charge flowing. So what is charge flowing? We will define it. First, there are from my childhood there was a doubt that in sea or beach I had gone first. In my childhood I had gone to the Puri beach where my parents tried to afraid me that there is a current inside the water, so don't go inside it. That means they try to teach me that there is a water flow, so don't go there. But I think that there is a electricity, so I was too much afraid. But actually that is the water flowing. There is no electricity inside the water, but actually there is the water flowing or water current. Understand? Similarly, if air will flow, we can say it air current, not the electricity. Here is not electricity. Inside air current, there is no electricity. But if the current will flow inside a wire, we can say that it is electric current. Understand? Then how will we define it in physics? Suppose here is the wire. This is suppose positive end. So this is the wire and this is the negative end. We know that inside a wire there is electrons which flow from negative to positive end. Understand? But there is the positive. Generally we know that the positive charge do not flow, or proton do not move. We know that from the in chemistry there is, we know that the inside the center there is proton and neutron, but electrons revolve around it. So if we remove an electron or if we give the electron, then it will become charged. So but we cannot try to take the proton out. So generally electrons flow so that charge will fill, but proton generally we cannot remove a proton from an atom. So generally we take the proton as whole. It is called as whole. Proton cannot removed, but electron generally transfer from negative end to positive end. But if you know the theory of relativity, suppose I will sit here on an electron and I will move, then what will I feel? I am at rest, but it will seem like the whole will move towards me. That means from the theory of relativity we can say that whole are moving from positive end towards the negative end. Whole are moving, but actually whole are not moving. It will seem like whole will move from positive end to negative end. So generally we take current as whole, not the electron. We generally the electron move, but we consider whole as the current. So it will seem like whole will move from positive end to negative end. Who cannot understand, then try to listen my word again. Understand? So we can understand better. Now we can say that current flow from, or electric current flow from positive end to the negative end. Understand? Now I will define electric current. We will define electric current. Suppose I will take this cross section. Suppose hole are moving from or passing by this section. Suppose some number of holes are passing by this section, or it will contain some charge. So take this charge of this. That means some charge is passing to this section. It will take some time t. Suppose I will take t. Suppose q amount of charge pass this cross section at time, or this is unit cross section, so in some time t. So we will define as current. That is, current is the amount of charge. Current is the amount of charge passing through a cross section in unit time. Or we can say that rate of flow of current. We can say rate of flow of current. Here I am mentioning the electric current. Rate of flow of electric current through a cross section of wire. It is called as the electric current. Then how will I mathematically how will I express it? Generally, current is denoted as capital I, and you know that charge is q by t. So I equal to q by t. Suppose here I will break this circuit. Suppose I will add here I will add a key, and I will off the key. Can I say the holes are moving from positive to negative end? No, I cannot say. That time if the wire will break, I cannot say that holes are moving or charge is moving from positive end to negative end. So if the switch is off, or if the wire is break, or inside the wire if the bulb is fused, we cannot say the current is flowing. Understand? So first, to flow a current or inside a circuit, first it should have to fulfill the current flow, or it should have to fulfill the circuit, so that we can say the electric current is passing. Understand? Now, what is the unit of electric current? Generally, unit will first, it is generally it is SI unit is ampere. SI unit is ampere. It is denoted as capital. SI unit is denoted as capital A. So we can say ampere equal to Q. The unit of Q is coulomb. Coulomb by second, or coulomb per, you can say coulomb per second, or ampere. SI unit is coulomb per second or ampere. Now, how will you define ampere? Ampere is the, if I will say, if here is 1 coulomb 1 second, if I will take 1 second, 1 coulomb by 1 second, then I can say it is 1 ampere. So I can say if 1 coulomb of charge will flow in 1 second through a cross section, then I can say, then it is called as 1 ampere. Understand? There are some another units also. You know that the term, there is some terms, that is milli, micro, nano, pico. You know that. Understand? I have taught you in class 9. So if there will be milliampere, then what will be it? 10 to the power minus 3 ampere. If there will be microampere, or it is denoted as mu a. Understand? It is small m, capital A. So it will be 10 to the power minus 6 ampere. You know. Similarly, it is n nanoampere, that is Na. If there is a nano ampere, then 10 to the power minus 9 ampere. Similarly, pico, that will be, it will be pico ampere equal to 10 to the minus 12 ampere. Similarly, pico atto, there is 10 to the minus 15 ampere. Understand? Millimicro, nano, pico, femto, atto, there is femto is 10 to the minus 15 and atto is 10 to the power minus 18. Understand? There is an electric instrument that is called ammeter. Ammeter generally used to measure the flow of current or to measure the electric current inside a circuit. Understand how it will be, then how it will be arranged. Suppose this is the circuit, suppose this is the positive end, this is the negative end. Generally ammeter is connect in series to measure the electric flow inside a circuit. Suppose here is two circuit. Suppose here is in general line, suppose here is positive, negative, then we will fix ammeter in series. Understand? Series means we will just connect through, in basic we can say connect through one wire. That means inside the to cut the section of the wire and feed the ammeter wire in one end, then another end. Understand? That is called the series connection. Generally ammeter is connected in series. Understand? There was a scientist named that is Andre Marie Ampere. To give him honor, the unit of electric current is ampere. That means the unit ampere is the name of the scientist, that is the French scientist, that is Andre Marie Ampere. We know that generally one electron occupy some charge or one proton, we can say. Suppose one proton or electron we can take. As I am taking the proton or electron, I will not take the sign. Just one proton or electron contains generally 1.6 into 10 to the minus 19 coulomb charge. So how much electron or proton will carry 1 coulomb charge? As we are defining as we are here taking the inside the definition of ampere, we are taking the charge that is 1 coulomb. So if in general, if we try to understand, it will how much electron will flow through the wire, how much electron will flow through the wire, so until 1 coulomb current will pass, then how much electron we will calculate. Now in 1 electron, that is 1.6 into 10 to the minus 19 coulomb. So if you take 1 coulomb, that means we have to divide 1 by 1.6 into 10 to the minus 19 electrons. This much electron will give 1 coulomb current. That means if you solve it, we will get 6.25 into 10 to the power 18 electron. This much electron will give you 1 coulomb charge. So that if suppose, that means if this much amount of electron will flow through the wire, we can say in 1 second we can say that it is 1 ampere current is flowing. That means this much amount of electron if will pass through a cross section in 1 second, then it will be 1 ampere of charge. Understand? Now in your NCERT book there is a question: a current of 0.5 ampere is drawn by a filament for 10 minutes. Find the amount of electric charge. How will you find? Now we know that there is the mathematical expression, that is I equal to Q by T. Here asking that electric charge, not the current. Try to understand. Electric charge is Q. So Q equal to IT equal to I is here given, I is electric current, here is current is given, so I is 0.5 into T is given, time is 10 minute, that means 0.5, here is ampere, 0.5 ampere into 10 minute, that is 600 second. So if we multiply it, then it will give 300 coulomb. Ampere into second is coulomb, it will be 300 coulomb of charge. Understand?